We're going to talk some more about our parallelogram family today. So we started with the 5 characteristics of a parallelogram. Every shape on this page is a parallelogram. So they're going to have these characteristics, plus they get a little bit more specific for each one. So for example, a rectangle is a parallelogram. That gives it all of the characteristics of a parallelogram with 4 right angles. So you know it's a rectangle first off we know it's a parallelogram, and all the angles are right angles. That makes it a rectangle. One of the things that's unique to a rectangle is that the diagonals of a rectangle are congruent. So if I connect my diagonals, they still have the characteristic from here that they bisect each other, but now, because it's a rectangle, the diagonals are equal to each other. And if you look, when you notice you're practicing, you'll notice that these 2 triangles are congruent and these 2 triangles are congruent. So they have a lot of things in common there. Then we move to a rhombus. A rhombus, we already mentioned, it's part of the parallelogram family. It's a parallelogram with 4 congruent sides. So all the sides are equal in a rhombus. So it's a parallelogram, all the sides are equal. A couple of things that are special about a rhombus: the diagonals are perpendicular to each other. So when I come in here and draw the diagonal from corner to corner, now remember, it's a parallelogram, so the diagonals bisect each other. But because it's a rhombus, here in the middle, these are right angles. And the next thing that the diagonals do, because it's a rhombus, the diagonals bisect the angles. So when I draw this diagonal, these 2 angles are equal. And because the opposite angles are congruent, this angle was bisected, those are also congruent. So these 2 angles are equal to these 2 angles, they got cut in half. And the same for these 2. These 2 angles and these 2 angles. They started out congruent and they were bisected, so now I have 4 angles that are congruent. That's a rhombus. So you may see some Pythagorean theorem involved because we do have right triangles. And the outside is the hypotenuse. So you might see some of that. A square finishes off our parallelogram family. I joke that a square is a rhomtangle because it's a rhombus and a rectangle. But a square is a parallelogram with 4 right angles and 4 congruent sides. So all the characteristics of a rectangle, because it has the 4 right angles, all the characteristics of a rhombus. So if I draw the diagonals through my square, these are perpendicular here in the middle. These are the same. These angles were just bisected. These angles were also bisected. So you'll see a lot of 45 degrees because that got cut in half. And the center's a 90. Let's do some practice that goes along with that. So if I go over to page 10 for special parallelograms, it says find the missing values in the rectangle. Alrighty. Well, first off, I know that if this part of the diagonal is 5, remember the diagonals bisect each other? This one's also 5. We also learned that the diagonals of a rectangle are congruent to each other. So these 2 diagonal pieces are also 5. T equals 5. Let's find some angle measures now. Since these 2 diagonal pieces are congruent, it creates a special triangle for us right here. Remember, if 2 sides are congruent, the base angles are congruent. So W is also 28. And if you remember the property of parallel lines where we had our alternate interior angles, if W is 28, guess what Z is? Z is also 28. Now if you remember, this entire angle is 90. So if I needed to find the other piece, I would just do 90 minus 28, and I believe that's 62 for the other angle. This wasn't asked in this question, but I thought I'd toss that out. Now, how am I going to find x? There are a couple of ways to do it. One is, well, let's add 28 and 28, subtract it from 180, and I'll get this angle. So 28 plus 28 is 56. So 180 minus 56 is 124. Then if you look at x right next to the 124, those two angles have to add up to 180, so x is 56. Some of you might recall this was the exterior angle theorem. That's the one that said the remote interior angles added together, remote interior plus remote interior, equals the exterior angle. So the 28 plus the 28 equals the 56. There were a couple of ways to find that, but that's probably the quickest way to get there. Number 2, find the missing values in the rhombus. So they're telling us it's a rhombus, so we know some things right off. We know that the opposite angles are congruent, and the opposite angles were bisected. D is 22 degrees. If this is 90, 22 plus 90, and then we subtract that from 180, I think we'll get 68 for F. So that means both of these angles are 68, which means E is 68, because our diagonal bisected that angle. Now I want to find X. So we're going to look here for a minute. I mentioned the Pythagorean theorem earlier, and here's where we're going to use it. I know that this piece is 5. The entire diagonal was 24, and because it was bisected, this is 12. So now a little Pythagorean theorem, 5 squared plus 12 squared equals x squared, and you find out that x is 13. So a little bit of work with a rhombus there. Let's take a look at the square. You're going to find the square is pretty simple. We know that all of the corners are 90, so that'll be easy once we figure out one of them. And remember the diagonals, because the square is also a rhombus, these are all 90 degrees because the diagonals are perpendicular. Now in the corners, we started off with a 90, and because a square is a rhombus, the diagonals bisected that angle. So these are all 45s, all the way around. So a square is pretty easy. All of the angles where the diagonals meet are 90, and all of the corners were 90 that got bisected to be 45s. All right, another rectangle. So let's look at our picture here. What do I know about this angle up here and this angle down here? Let's take a look at what we know. I've got my parallel lines right here. So I know that 3x plus 8 is congruent to this angle. And if you remember from our previous picture, we talked about this being an isosceles triangle. So if this angle also measures 3x plus 8, this triangle down here, because remember those diagonals were congruent and then cut in half, so I can simply say that x plus 22 has to equal 3x plus 8. I'll subtract x, subtract 8, and it looks like x is 7. So I get this angle's 29 degrees, this angle's 29 degrees, and that works. Now let's look at this diagonal. I know that the entire diagonal from A to B is 5y minus 2. And then I know that this portion from here to here is 3y plus 5. Now the diagonals are equal and they've been cut in half. So I know that 2 of my 3y minus 5s are going to equal the 5y minus 2. 3y minus 5 is half a diagonal. The other half is also 3y minus 5, and it's equal to AB. So now I just do my algebra. 6y minus 10 equals 5y minus 2. I subtract y. I add 10. Y is 8. I can double check. 5 times 8 minus 2 is 38. 3 times 8 is 24. Minus 5 is 19. If I take both of these 19s and add them together, I get the 38. We're looking good. One more. It's another rhombus, and we want to find the length of AC. And they've given us a couple of things. They told us that BC was 17, and now they said that BD, the entire diagonal, is 30. Now we know that in a parallelogram, the diagonals bisect each other. So this section is 15 from here to here. So how am I going to find this part? Well, the diagonals of a rhombus are perpendicular. I'm going to do the Pythagorean theorem. 17 squared equals 15 squared plus b squared. And we're going to calculate and find out that b equals 8. So if this is 8, what is the measure of segment AC? Remember the diagonals were bisected, so AC is 2 of them, and it's 16. So use your characteristics of your special parallelograms to solve these practice problems.